For this presentation of Creo sheet metal design capabilities, I'm actually going to start with a solid part that's got some lines and arcs and so forth, and actually was an imported feature. So it's kind of the most challenging capability here. This is a big blob, but I want it to be sheet metal. So let me turn on the rest of these features just so you can see what we're working with here. Again, I've got some holes cut out, got some rounds, so maybe I took that and I started with. But now I want to go ahead and keep all of this, but I need to turn it into a sheet metal model. So what can I do with it? Well, the answer is you can do a lot. So we'll start with the conversion process. So if I say convert to sheet metal part, I can define a driving surface and say, yep, this is the piece I want. Automatically looks at how thick is this piece and then understands this is going to be sheet metal, so what size thickness do you want? And I'll say, okay, that's a good start. So now I've essentially got a flat piece. It's got all the cutouts that were defined in that imported model, and now I'll keep going. So I need to put a flange over here. So notice almost everything in sheet metal is instant preview. I need a flat flange, pick an edge, and I get a preview. So then I can start moving it around, adjust the edges, adjust the angle. Where is the thickness being added, inside or outside? What sort of shape? Is it rectangle, L, T-shape? Maybe in this case I want to do user defined because I've already got some lines and arcs that I can use. All right, so I'm going to just say sketch, and then grab this loop there, and say that's what I want to use as my piece, right? So now I can say delete that bottom edge, and there's a flange. So just like that, I've made a new flat wall. Lots of details of how do you want to fabricate this? How do you want to do bend reliefs, corner reliefs? All of that can be customized as you go through. All right, so that's a good start. Now maybe go ahead and take some of those other curves and let's make holes. So these are just simple extrudes. They are extrudes that also understand the direction of punching. How do these holes go through? Are they laid out in the flat? How are they created? Let's create a flange wall. So a flange wall, I can grab multiple edges and say take the whole edge, or in this case I want to back it off of that corner down there, so let's give it a value. Same thing here, maybe I want to back this off so I can drag it and visually see what I've got. Go ahead and give it firm values. Say let's come off 10 millimeters. What's the height we want for this new flange wall? And notice how it automatically creates and previews all of this geometry, so you can really see what you're doing. I mentioned earlier, maybe you want to customize. You have a default bend relief, maybe is rip, but no, for this one, we're going to go do a rectangular rip on both sides, and I'll go ahead and set the sizes. So in every case, when you build features in sheet metal, you start with defaults and then go ahead and customize them. So you can set it up really the way you want. So in this case, the corner reliefs between these different flanges, I want to go define those as maybe an odd round. We're going to punch out there. And there I've got a nice flange wall that wraps around three sides of this piece. All right, so it makes it really easy. Just go ahead and define the different shapes. In addition to flanges, again, you can go ahead and cut material out. Maybe you're going to rip this piece and actually do a new bend there. So let's do that. So I'm going to cut out some basically relief hits there. And then I'll say rip connect. So basically I want to say take this point to this point, and let's assume that geometry can be pulled away, because that's exactly what I want to do. Is now take this edge that we just created, let's put a bend on it. And so all I have, a lot of different ways to do it, but in this case, all I really have to do is grab that edge that we just created with the rip and say bend it. So now it takes that geometry, including those holes that are punched there. It understands how sheet metal is fabricated. Again, best practices, do you want to put in different types of bend reliefs? In this case, yeah, let's do some mob round cutouts there. So go ahead and set the size the way I want, the thickness, something like that. So now I've created a bend on material that I've ripped and pulled up. So just like that, makes it real easy. So in addition to the flanges, the walls, the different rips and so forth, you can also do form features. So in this case, just a simple sketch form. I already had a definition there, so let's go ahead and grab that sketch. Let's say extrude it a certain distance, essentially punch it so far, and maybe remove those outer edges. And just like that, I've got an extruded form feature there. Makes it easy, so different ways to go about it. Now, one of the biggest changes that happened a couple of years ago within Creo is the ability to do flex modeling specifically on sheet metal. And that's a biggie. A part like this, that was all these internal holes are imported, right? There's no sketched feature there, but I may need to make changes. Well, with flexible modeling, I can do just that. I can grab a single edge and move it. I can say, recognize this as a cut and take that geometry out. Now I just have clean, flat sheet metal right there. Here's some cutouts. Maybe I need to make some modifications there. Well, first thing I'll do is say, recognize not only is this a cut, but look for a pattern. And there was no pattern in this model. I simply say, I want to recognize it. And once I've done that, well, then of course I can edit it. So maybe instead of 3 at 32 degrees each, I want 4 at 30 degrees. Well, now I've got additional things. So I'm adding the intelligence that I need into this model, even though it came in as an imported piece with flexible modeling and with the ability to do flexible modeling with sheet metal. I can make all sorts of very fast modifications. Maybe the central cutout here, it's got to be bigger. Well, let's just grab those edges and say offset. Very fast and easy. So different ways you could go about that. You could do it as a standard cutout, but this is really puts in the design intent. If I grab the left side of this pocket, match it with the right side and say substitute. Well, I got one single bigger pocket as far as the sheet model is concerned. Same thing here. Maybe we don't need this. We're going to put some stiffening beads over here. So first thing first, let's remove that cut. So I recognize the cut and said remove. And then let's do some more regular sheet metal design. So in this case, maybe a form feature. Use a punch form where I've actually modeled the form itself. So in this case, again, just more of a stiffening bead. Says, okay, where do you want to place it? Well, I'm going to place it on that face. So the back side. And then how are we going to locate it? Well, this one has 2 locators, so it's basically located left and right, top to bottom. We'll go ahead and use the default datums to do that. That allows me both to move it there and then set it to a real value. Okay, so let's set 60 there. And now I've got a punch form feature. Roll it around. Again, it understands how sheet metal is fabricated. It's not just cutting pieces and so forth. It'll actually put in the adjacent radii and so forth per your form tool. Any feature like that, that's a Creo parametric feature. I can go in and say, oh, yeah, let's pattern that one. So we need a couple of them. So I'll go ahead and grab this edge as the directional dragger. Say maybe 30 millimeters. Something like that. That looks good. All right, so that's the idea. You start with whatever you have, in this case an imported feature, customize it. Here, let me turn on the flat pattern. This is a separate window I can always look at and work, understand what I'm creating here. But I basically took that original geometry, used the conversion tools, used the sheet metal flange and flat walls, extrude to do cutouts, and then used flexible modeling to make changes to existing geometry. All of that's available within Creo and sheet metal design.